of a stress that is a change in the concentration. So here we go. So here we have our reaction, okay? And so we're going to say that the O2, this is going to be the stress. So in this example, O2, this is going to be the stress. And O2, more O2 was added to the system. So take a look at this. So we're going to first find that O2 is on the left-hand side of the reaction. So the stress is a reactant, right? So the stress is a reactant. Something has been added. So the system, it will shift away. It's going to shift away from the reactant. So that means to readjust for this stress, the system, it will shift away from the reactants. The reactants are on the left side, so it's going to shift to the right. So if the stress is an addition, we find that the stress is on the reactant side. It's an addition, it shifts away, so that means the system shifts to the right. Let's take a look at another example. So this time, our stress is going to be H2O, and more H2O was added to the system. So this stress, take a look, it's to the right of the arrow. So this time, the stress is a product. And because it was added to the system is going to shift away from it. I'm trying to write the word away. So the system's going to shift away. Well, away from the product side is shifting towards the reactants, the left. So in this scenario, the stress is going to cause the system to shift left. Let's take a look at another example. So this time I see that NH3 is going to be the stress, and NH3 was removed from the system. So here we go. NH3, the stress of removal, the stress is a reactant. NH3 was removed. So when the stress is a removal, the system will shift toward the stress, which means the system is going to shift towards it. It's going to shift to the left. Let's take one more look here. So in our system, this time, NO is going to be the stress, and some of the NO was taken out. So it was taken out of the system. We see that NO, the stress, is a product because it's to the right of the arrow. So the stress is a product. And when the stress is a removal or something has been taken out, it has to be replaced. So the system is going to shift towards it. Which means if it's shifting towards this stress, the direction of quote unquote towards is the system will shift right because the stress is a product. So first be able to identify where the stress is in the reaction. If the stress is an addition or a removal, something's been increased or decreased, and first identify the direction of the shift. That's your first job. The second job is sometimes to figure out, as the system is shifting to the right or to the left, what are the changes that occur? Like, why does it happen? So when we take a look at the first one, let's write down some reasons why. So now we have too much O2. So we have extra O2 in the system. There's too much of it. So the system has to use up some of the extra O2. So the system uses up the extra O2. Well, how does it use it is going to be the big question. Well, O2 is a reactant. So the forward reaction, reactants making products, is favored. So the forward reaction, reactants making products, is favored. So the extra O2 reacts with NH3. So the extra O2 reacts with the NH3. And I know that because NH3 is also on the reactant side. So the extra O2, it reacts with NH3. The elements within these substances don't disappear. When they react, they make more of what's on the product side. So let's start here. So this stress, it needs to be used up. Well, it's used up by reacting with NH3. So that means some of the NH3, its concentration is going to decrease because it's being used in the reaction. The nitrogen, the hydrogen, the oxygen being used in the reaction are not disappearing from the system, right? They are reacting, bonds are breaking, and they're forming more nitrogen monoxide. So there's going to be a slightly higher concentration of the nitrogen monoxide, and a higher and more water is also being formed. So its concentration goes up. As these two react, they release heat. So they make more products and release heat. So the forward reaction is exothermic. So if you went and touched the glass, okay, this would be warmer because it's going through an exo process. So there'd be more heat in the system. If we take a look at the next example, okay, now the stress is H2O. So like before, now we have extra H2O. The system needs to use it up. So uses it up, okay? Well, how does it use it up? Well, H2O is a product. So, and the system is shifting left, so that means that in this scenario, the reverse reaction is favored. The products are being used to reform some of the reactants. So the extra H2O reacts with the NO. And in order for these two to react successfully, they have to absorb heat. And the result is they make more of the reactants. So this stress, it has to be used. Need to be used. And the way it's used is by reacting with the NO. So the amount of NO in the system, it decreases. There's going to be a little bit less. The NO and the H and the O from the water, they don't disappear in the system, but they are reformed as O2 and NH3. So now, as the system shifts left, we're going to see O2 is being made, so its concentration goes up, and the same thing with NH3. Some of it is being made, its concentration goes up. The heat is being absorbed, so it's participating in an endotransfer. So that means if you touch the side, it's going to feel cooler. So the energy is going in and being stored and trapped in the bonds, so there's less heat available to the total system.